Hello viewers, in today's session we are going to discuss a very important and interesting problem from differentiation, right? And this problem is going to be very conceptual because here we are going to find out the derivative of mod of trigonometric function, right? So let us start. So viewers, we have already discussed a lot of similar problems in our earlier videos, and here we have a very new problem related to differentiation of mod function of trigonometric functions, right? So here we are given this problem in which the function y is equal to negative of mod of cos of 2x minus mod of cosine of 3x over 2, and we have to find the derivative, that is dy over dx, at this point x is equal to 5 pi by 6. So in this problem, we are going to use a variety of concepts from trigonometry, and we'll also see how we can utilize the sign convention of trigonometric functions in the different quadrants, that is in the four quadrants. So beside the concept from trigonometric functions, we'll also see how we can apply the definition of mod function to these two expressions, that is mod of cosine of 2x and mod of cosine of 3x by 2. So let us start with this number, that is x is equal to 5 pi by 6, right? Now see, we have to find the derivative of y with respect to x at this point, that is 5 pi by 6, right? Now see, here we have mod of cosine of 2x. And now if we look at this angle, then we have 2 times of x, right? So 2x is equal to 2 times, because we have to evaluate the derivative at this point. So we'll take x is equal to 5 pi by 6. So here we have 2 times 3, that is 6. So we have 5 pi over 3. Now this is in radians, and if we convert it into degrees, we'll get 5 over 3 times 180 degrees. So we have 3 times 60, and this is 300 degrees, right? So 2x is equal to 300 degrees, right? Okay, now let us consider this angle. So here we have 3x over 2. Now 3x over 2 at x is equal to 5 pi by 6 can be written as here, substituting x is equal to 5 pi by 6. We have here 3 times 2 is 6. So we have 5 pi by 4. 2 times 2 is 4. And again, converting this angle into degrees, we have 5 by 4 times 180 degrees. So this is 4 times 45, and this is 5 times 45 is 225, right? Okay, so now we have these two angles. So let us write them here. So 2x is 300 degrees, and 3x over 2 is equal to 225 degrees, right? Okay, so now let us consider the four quadrants. Now here, this is the first one, this is second, this is third, and this is fourth. And here we have 0 degrees, this is pi by 2, this is pi, this is 3 pi by 2, and here we have 2 pi, right? Okay, so now these are the four quadrants, right? Now the first angle, that is 300 degrees, it falls in the fourth quadrant, because 3 pi by 2 is 270 degrees, right? So 300 degrees, it lies in the fourth quadrant. So here we have 300 degrees, right? So this is 300 degrees. So this is our angle, 300 degrees. So 300 degrees falls in the fourth quadrant, and we know that in the fourth quadrant, the cosine function is positive, right? And the second angle, that is 225 degrees, it falls in the third quadrant, right? So it lies somewhere here, and this angle is 225 degrees, right? And in the third quadrant, the cosine function is negative. So this is an important concept while finding out the derivative of mod functions of trigonometric functions, right? So we have to see the quadrant in which the angle lies. So here 300 degrees lies in the fourth quadrant, and in the fourth quadrant the cosine function is positive, and in the third quadrant we have the angle 225 degrees, and in the third quadrant the cosine function is negative, right? So now quickly see the definition of mod function. Now see, a mod of p is defined like this. Mod of p is positive p whenever p is greater than 0, and mod of p is 0 whenever p is equal to 0, and mod of p is negative p whenever p is less than 0, right? So now let us consider the first expression, that is mod of cos 2x, right? Now see, this angle 2x, this angle is 300 degrees. So here we have the cosine function positive in the fourth quadrant. So we can now write mod of cos 2x as positive cos 2x by virtue of this definition, because cosine function is positive in the fourth quadrant, right? And if we take the second function, that is the mod of cosine of 3x over 2, then this angle 3x over 2, it is 225 degrees, and it lies in the third quadrant, and in the third quadrant cosine function is negative. So we can now write negative cos 3x over 2, right? So now this function, that is y, it takes the form minus, here we have the negative sign, then mod of cos 2x is positive cos 2x, and then we have minus, and here mod of cos 3x over 2 is minus cos 3x over 2, right? So now we can write y is equal to negative cos 2x, and minus minus becomes plus. So here we have cos 3x over 2, right? So finally, by applying all these concepts, our function y, it now reads as minus cosine 2x plus cos 3x over 2, right? Now let us find out the derivative of y with respect to x. So the derivative of cosine 2x is minus 2 sine 2x, and here the derivative of cos 3x over 2 is minus 3 by 2 sine 3x over 2, right? So now we can write minus minus becomes plus, so we have 2 sine 2x, and here plus minus negative, so here we have 3 by 2 sine 3x over 2, right? So the derivative, that is y prime, is now given by this expression. So now we have to find the derivative at this point, that is x is equal to 5 pi by 6, right? So we have y prime at x is equal to 5 pi by 6. So here we have 2 sine 2x, right? Now 2x is equal to 300 degrees. So 2x is our 2 times 5 pi by 6, and then we have minus 3 by 2 sine 3x over 2. So we have 3 by 2 times 5 pi by 6. So this is 2 sine, that is 5 pi by 3. And here we have 3 by 2 sine. And here we have 3 times 2, 6. So we have 5 pi by 4, right? So now our aim is to get the value of sine pi by 3 and sine 5 pi by 4. So for getting the value of these two expressions, we'll make use of some trigonometry. So whereas although we can find out the values of sine 5 pi by 3 and sine 5 pi by 4 directly by using a standard trigonometric table, but here we'll find the values of these two expressions separately for the benefit of viewers, right? So here we have sine 5 pi by 3. Now splitting 5 pi by 3 like this, sine 2 pi minus pi by 3, right? Because 3 times 2, 6, and 6 pi minus pi is 5 pi, right? Now here we can use the standard result, that is sine 2 pi minus theta is equal to minus sine theta, right? So here theta is pi by 3. So we have minus sine pi by 3 due to this result, and sine pi by 3 is sine 60 degrees. So this is minus square root of 3 over 2. And similarly here we have sine 5 pi by 4, and again splitting 5 pi by 4 as pi plus pi by 4, right? Because 4 pi plus pi is 5 pi. And now we can use this result, that is sine pi plus theta is equal to minus sine theta. So here we have minus sine pi by 4, and sine pi by 4 is sine 45 degrees. So we have minus 1 over square root of 2, right? So sine 5 pi by 3 is minus square root of 3 over 2, and sine 5 pi by 4 is minus 1 over square root of 2. So now the value of the derivative at x is equal to 5 pi by 6 is given by 2 times. Here we have minus square root of 3 over 2, and here we have minus 1 over square root of 2. So here 2 and 2 get cancelled. So we have minus square root of 3, minus times minus, this is positive, and we have 3 over 2 times square root of 2, right? So the value of the derivative of y with respect to x at x is equal to 5 pi by 6 is given by this expression, that is minus square root of 3 plus 3 over 2 times square root of 2. We can also express it like this, that is minus root 3, this is 3 over 2 root 2. We can rationalize the numerator and denominator by square root of 2. So this is minus square root of 3 plus 3 root 2 over 4, right? And now taking LCM here, we have dy over dx is equal to minus 4 root 3 plus 3 root 2 over 4, right? So this is our required expression for dy over dx.